Example 1.6. Specify the resistance source so that both of the following conditions are satisfied. The current has to be greater than 40 milliamps. 2, the power absorbed by the resistor is less than half a watt. Okay, let's look at these things. So what we see here is that there are two conditions. Placed on the value R. What the heck is that? So let's look at condition 1. So the minimum current is I min has to be greater than 40 milliamps. So this implies here the maximum resistance, R max, is determined by Ohm's law. So if I look at my circuit, I have 10 volts. I have one resistor. And we know that this resistor has to be the maximum possible resistance. So now if I look at my current, I could see that my current is coming in like this, and I'm going to say that that current has to be my minimum current for the circuit. So from Ohm's law, we see that the current min must be the voltage source divided by R max, which then tells us that R max must equal the minimum, that is, let me be careful, that is that critical point has to be this guy right here. So if I plug in my values, this is going to be 0.04 amps. This is going to be 10 volts. So this gives me 250 ohms. And that's the maximum possible resistance that we can have. So if I look at condition 2 now, so if condition 1 gives R max, then condition 2 must give R min via power. So all we know here is that the power dissipated must be less than PR less than half a watt. So if I now look at the minimum power, then that's going to give us VS squared divided by R min. So now if I solve for R min, this will give us V source squared divided by P min. Oops. So if I look at these values, this will be 10 volts squared divided by half a watt. So then this equals 200 ohms, and this will be the minimum value. Therefore, the range of the value R lies between 200 ohms and 250 ohms.